Welcome, welcome to part 5 of the project tutorial. So in this part we will address how we can represent multiple ships in the game and how we can place those ships on the board. So last time we left with this initial implementation that allows each player to position 7 cells on the board and print these boards. So let's take a look. Let's assume we have 2 players. The first player is a human player, so this player will enter the columns, the pieces, by entering coordinates. So the lack of creativity, I'm going to do 2, 2, 3, 3, 4, 4, 5, 5, 7, 7, 6, 6, and then 7, 7. Right? So that's my board. The computer player initialized the board by drawing on some random coordinates, and this is their board. Now what this implementation assumes is that each ship is one cell, right? So it's like positioning tic-tac-toe tokens on the board, but we know that the ship has a certain shape. It's not one cell, there are multiple cells, and there are different ships from different shapes. So what we're going to do now, we're going to take a look and start thinking about improving this implementation to take into consideration the shape of the ship. So the main method is actually splitting the job of setting up the board in between the 2 players. There's a game, and the game has 2 players, and each player will be responsible on initiating their own boards, printing their own boards, and also shooting, which is still an empty method. Well, the method initiate board in the class player will take a look, examines the type of the player. If the player is human, it will initiate board by thinking. If it's a computer, by computing. Those methods will initiate the board differently. The think method will actually probe input from the keyboard. With the method compute will basically generate these things randomly. Now once this is done, both of these methods will call the method place ship from the class board, and this method takes the coordinates, row and column, and the ship to be placed, and place that ship on the board. Now this method actually doesn't even examine ship, right? It only places one token on the board. And what we need to do, this is where we left some to-do items to complete, is to basically take into consideration the shape of the ship here. So this placement needs to be further elaborated and depend on what kind of a ship object we are providing to this method. So now let's think about what's inside the class ship. We tentatively said that there is some coordinates x and y. We're not sure how to use them yet, but there's also probably, and most importantly, the shape of the ship. Now, how is a shape of the ship presented? Let's say, for instance, you have a ship I, which has four cells in sequence. Now, those 4 cells are basically an array. So we can think about the ship also as an array of cells. And this array is unidimensional in the case of the I ship, either when it's horizontal or vertical orientation. But in general, it's not a unidimensional array, it's a 2-dimensional array. If you think about any other shape like the square, S, or the T, they're basically their own 2-dimensional array, and each one of them, each array contains information about cells that contain the ship and cells that don't contain the ship. So let's think, for instance, about the L chip. Well, the L chip looks like something like this. L, L, let's do a space, L, L. So that's an L chip, or maybe two, right? Now those, you can think about those as C items or vacant item in the ship. So one way to represent the ship is to store a two-dimensional array indicating what cells are ship cells and what cells are not ship cells. Right? Of course, if all of the cells are ship cells, means that the ship is occupying this whole array. And this is the case for some of them, like square, because it's like an array of 3 by 3, and all of them are ship cells. So since I'm thinking about this dichotomy between a ship cell or not ship cell, I'm going to start with a tentative implementation using a Boolean double array. I'm going to call it cells. And my thinking in here is that each cell is true or false, and this will determine the shape of that ship. Now, of course, we've got a bunch of ships here, but I'm going just to simplify things and assume that I only have one shape of ship. Let's do the L shape, for instance, and then we can think later of how we represent different shapes. So what I'm going to do, I'm going to provide the implementation of the constructor. And in this implementation, I'm going to create an L shape by creating a new Boolean array. So the L shape, let's do it, let's represent it one more time here as we've got 3 rows and 2 columns. 3 rows and 2 columns, right? And what's the content of this? 0, 0 is true, 0, 1 is false. 1, 0 is true, 1, 1 is false, and so on. Right? So I'm going to translate this. So 0, 0 is true. Cells 0, 1 is false. That's basically, this is what I'm trying to do. True, false, and then true, true. That's basically the L shape that I'm trying to represent here. So 0, 0 is true, 0, 1 is false. And then we've got 1, 0 is true, 1, 1 is false. And then 1, 2, 0 is true, and 2, 1 is true. So that's the basic idea. Now, of course, this only represents one ship, so it's limited. So maybe we need to think about a constructor that takes the ship type as a parameter. We also want to think about methods like rotating the ship that will change how the ship looks like. But again, once we settle on that internal representation, the remaining stuff becomes filling in the details, right? So the method rotates will operate on cells and rotates that two-dimensional array, for instance. Okay, we can think about providing helper method, such as the method to print the ship. I'm going to create a toString method because when I want to interact with that player, I want to display the ship to them, so it makes sense to create a toString method here. So output will be initially empty. I'm going to return output, and then I can do each row inside the cells. And then what I can do, I can go for each column associated with that row, so cells r.length, column plus plus. And what I can do, if cr cells rc, and of course this is Boolean, so nothing needed, it will be either true or false. If c, then I can do out, will be out plus maybe x, I'm not sure, x else out will be out plus O. Of course, probably it makes sense to make it C and ship like we've done in the class board, right? So it makes sense to use these characters. So maybe I'm going to use them. So instead of recreating the wheel here, I'm going to use ship. So board.ship. It's not board, it's board.ship. And then board.c. So that's the class board. And then I'm trying to access it here. Static reference to non-static field board.ship. So since I'm trying to access those on the class, they have to be static. Of course, because their values don't change across all of the instances, I can make them static. So that will solve that issue. It's actually R, not I. And this one, cells C is less than cells R.length. Else out will be board dot C maybe. So that's that. Once we're outside of the second loop, which is this one, so we're back to the first loop, put brackets here. We can add a new line to out so that it shows up on a new line. And then this is kind of a working implementation of ship. It creates the same ship all the time. So we go to game, for instance, and let's actually try to comment out this part for now, because I'm interested in class ship here. So I'm going to create a new ship, and let's print P. If this works fine, we should get that L-shaped ship, and this is what we have now. So then with this ship, let's try to place it on the board. To return this code to live. So placing it in the board is basically what the class board is trying to do. There's the method place ship that takes that ship object as a parameter, and then it tries to place it in the correct coordinates. Also, there are a couple of things. There's also the task of checking that the input is valid. Let's ignore this for now. This is not what we're looking at right now. We want to put this ship into the board. How do we do that? How is the data stored in board? Well, board is a two-dimensional array of characters, and we use characters because there are different values, like the OpenC, ship, hit, or miss. And ship represent its data as also two-dimensional array of booleans, because there are only two values. So what we can do, we can basically copy the content of cells in SHIP to the content of cells in board, but make that conversion happen. If it's Boolean, it has to be SHIP. If it's not Boolean, it has to be OpenC. Very much like this method is doing by making that conversion. So what we want to do, we want to make this copy starting from row and column. What I'm going to do, I'm going to ignore row and column for now and just assume that I want to place this in the very first location on board, 0, 0. So how do I do that? So let's take a look at the board one more time. This is the board. Let's say I want to put the L-shape ship in this one starting at location 0, 0. So I want to go over each cell and basically copy it on cells on board. So this is also a loop that goes over each cell in SHIP. So this is basically what we wrote in the method toString in SHIP. So let's leverage this code here. This is the loop that we are interested in. But we're interested in this in the class board. So if you go to the class board, cells in board refers to the two-dimensional array, which is the two-dimensional array of characters. And this is not what we're trying to do. We're trying to go over the cells in SHIP. So one way to do it is to expose cells in SHIP, make it public, right? And we go back to board and say, well, this is not cells in board, this is cells in SHIP, and SHIP here is P. This is P. And of course, this has to do something else than out. So let's take that for now. So that's fine, except that we expose an attribute to the outside. What makes sense from a design perspective is to hide cells, make it private, and provide methods to access its content. So let's do this. Instead of exposing this as a public attribute, let's make it private. And let's create a couple of methods. Let's see what we need here. We need a method that returns the number of rows here and number of columns here. And we need a method to return a certain cell. So that's what I'm going to do. I'm going to provide a method, a getter method, get number of rows, and this one will return cells with length. And I'm going to provide another method, get number of column, and this one will return cells 0, doesn't matter here, right? Dot length 0 or 1, that's the number of columns. And then I'm going to provide a third method, boolean, get cell at a certain row at a certain column. Then I'm going to return cells row column. Of course, it's Boolean because this is Boolean. Now, in this method, of course, we want to do some verifications just to ensure that this is valid input. Assuming it's valid input for now, let's go back to board. So that's rows. We get number of rows. And here we do p dot get number of columns, and this is p dot get cell at RC. So that's what we're doing now. Now we want to copy this into cells here, right? Actually, let's take out this code because this is placing one token. So this is what I'm going to do. This dot cells location R, row R, column C will be SHIP. because if this is Boolean, it means there is a ship. If this is true, it means there is a ship. Otherwise, it will be C. So basically, we're taking out those different cells and placing them on the bigger board. Now this is completely ignoring row and column, so this is always placing them in the beginning of the board. But this is just a start, so let's see. I'm going to enter coordinates 3, 3, and again you see here that the chip is placed in the beginning, right? It's supposed to be placed 0, 1, 2, 3 here. But this did not happen because we ignored that input here. Oh, but it's operating fine. Of course, it's overwriting the same over the same board, which also needs to be fixed. But anyhow, let's fix the placement logic here. What do we need to do? Well, we want to adjust that location by the row and columns that we are getting here. So instead of placing this in cells RC, we want to add row and column to R and C. So basically shift that placement depending on the row and column entered. So to understand it, let's assume row and column are 0, then we place it at R and C, right? If they're not 0, we want to shift that placement with whatever values that user has entered. So that's doing the shift here. So this to do is done. Ship is not a square anymore, but we still need to check for valid input. So let's go now to game. Try one more time. AI. Let's do 1, 1. And you can see that the ship is placed in location 1, 1. For the sake of the example, let's do 0, 1, 2, 2, 0, 2. So just kind of sticking it to the, so the column should be 2 and the row 0. So we kind of stuck this ship to that ship, right? Just shifting it. I don't want to think anymore, so let's do some easy numbers. So let's do column 5, row 0. Okay, column 7, row 4, column 7, row 0, column 0, probably row 6. That's that. And I'm kind of careful here because there is no validation here, and if I enter a large value, it's going to be an out of bound pretty easily. And let's try one for the sake of the example. Well, let's finish our ships, because once this happens, the other player, the computer player, will try to place its own ship. So the code sort of works, but we will bump into an out-of-bound index error, because here we're pretty guaranteed that the beginning location is within bound, but next we're shifting it, we're adding the size of the ship, which means there is the danger of going out of bound, which will probably happen with 7 iteration inside this loop. So I'm going to finish my own ships. Let's see how the computer player will try to place its own ships. So how about column maybe 8 or maybe 9, 0. Oops, I've done it myself. I just created an index out of bound exception because I've gone over with column 9, 0, 1, 2, 3, 4. Actually, it's not me, it's the AI player. It tried to go over the bounds here, 10, which was my initial expectation here. Okay, so of course there is some work to be done here in both situations, because the human player can also go out of bound. Like you start with, I don't know how many columns, 15 maybe? 15, so column 15, 0, and this will create an index out of bound. The AI player is also kind of prone to the same mistake. So the same to do about placement here needs to be addressed. Of course, there are so many other things, including rotating the ship if the input is -1, and also including representing different kinds of ships. This is possible, for instance, by considering an input to the constructor that takes, for instance, shape and rotation, shape, and of course you can create the ship depending on the shape and rotation. So shape will be, for instance, T, I, O, square, and all of these different shapes that you can take a look at the details in the specification of the project. I hope this provides enough guidance for the next step. And we will stop the tutorial at this point.